So we're going to be talking to you today about the implementation of a strategic campus sustainability and energy plan. This is obviously for University of Central Florida, here henceforth known as UCF. I don't want to get yelled at by Nate for calling it Central Florida. Don't use those terms. A little bit about us. My name is Wade Conlan, Penn State grad many years ago, moved into the design realm. Got to work on a lot of laboratories, chiller plants, healthcare, themed entertainment, some complex systems that led itself into naturally troubleshooting, which into commissioning. And I've been doing commissioning solely for the last 10 years. This is Nate Boyd. He's currently the Associate Director at UCF for the Energy Services. Nate had a winding route to that position. He started out doing controls for 18 plus years, pulling wiring, programming, troubleshooting, leading projects, etc. The way Nate says it honestly is, I got tired of design engineers telling me I was just a controls tech and I didn't know how it was supposed to work. So he went and got himself a degree, proud UCF alum. A couple different positions that he's held. He was a the energy manager for the city of Orlando, had a very large portfolio, large energy consumption cost for the year. He also worked at Hanson for a bit doing commissioning and energy projects until he went back to UCF to be more on the owner's side. It seems to suit Nate a lot better. So brief agenda about what we're talking today. Nate's going to go over the university, a little bit of a background and their plans and the progress to date. We'll get in talking about how they've actually achieved or what they've done or planning to do in terms of tools for making it happen. And then Nate will get into some carbon neutrality, smart grid, et cetera. Talk a little bit about results. Actually, shouldn't really say results. It should be almost the progress status or current status because it's an ongoing thing. And then we'll wrap it up so everyone can get out and grab some lunch.
Yep. All right, so a little bit about UCF. We are Orlando's hometown university. And really until a rather recent football success and basketball success, not a lot of people had heard about UCF because we're only 50 years young. But we're a sprawling campus. We're over 1,400 acres situated on the far east end of town. We've got about 20,000 tons of mechanical, refrigeration and chilled water flowing around that campus, and a nearly 800 million kBTU per year source impact on the environment. So UCF is a major economic and major environmental player in Central Florida. And we are by far the largest university in the state, if not one of the largest universities in the entire country. So the department that I represent is Utilities and Energy Services. As Wade said, I'm the Associate Director for Energy Services. So we are on the demand side management side of that. But UES, our mission statement is to provide safe, reliable, and efficient utilities to all of the campus buildings, assets, infrastructure for use by students, faculty, staff, and the greater academic mission of UCF as a whole. And so in order to be able to really accomplish our mission, it's important to take just a minute and tell you a little bit about how our department is structured, because this is important for what you're going to hear later on. We're broken up into 3 groups. Smart Infrastructure manages all of the servers, the databases, the IP addresses, the BBMD tables, all of the minutia of actually maintaining all of the licensure for softwares and the applications for all of our building automation systems, our GIS and mapping information, all of our billing and metering infrastructure, as well as our fault detection and diagnostics and our advanced analytics platforms. The energy services team that I manage, like I said, we're responsible for demand side management and trying to keep that utility expenditure as low as possible. And we do this through basically managing all of the energy audits and modernization projects, retro commissioning, and the renewable energy projects themselves. And on the utility distribution side, we procure utility or electric utilities. We also generate on site. Like I said, we generate a significant amount of chilled water. We also manage all of the natural gas, as well as water, wastewater, and we're about to be bringing on board stormwater into our portfolio as well, although I have no idea how we're going to generate a revenue stream from that.
You'll figure it out.
Yeah.
You've been told to, so you'll figure it out.
I've been told to, so we'll get there. All right, so these are some of the guiding policies and documents that really, they're important and for an owner of any kind of large portfolio or structure to actually have some documents that have some teeth built into them so that you can enforce particular policies. The collective impact strategic plan really is the guiding document for UCF right now, and it feeds right into the campus master plan. The climate action plan is something that was put together about 10 years ago. It's constantly being updated as well. And that's where UCF signed, basically we call it ACUPUC, to commit to being climate neutral by 2050, which for a university of our size is going to be a significant challenge. The energy and sustainability policy is the backbone behind what really gives us the power to be able to move forward with the policies and procedures that get this university pointed in the right direction from an energy efficiency perspective. It established the creation of our department. It authorizes it basically gives us teeth to enforce commissioning on every single project that happens at UCF. And so what has this resulted in so far? Well, over the last 12 years, we have been able to reduce notice this is source, we have been able to reduce our source EUI 42% over the last 12 years. Now that's a pretty incredible feature or figure, and this is despite the fact that UCF's campus square footage has been continuously growing. As we call ourselves at UCF, and even when I was a student, UCF stands for under construction forever. Now, we're able to realize those types of savings through a number of different innovative concepts and programs that we've implemented at UCF. We have our own on-site cogeneration plants, 5.5 megawatts. It has just recently passed 200,000 megawatt hours of production. We have just recently opened our 4th district energy plant. That brought us from 16,000 to 20,000 tons. We now have N+2 redundancy on our campus chilled water loop, which is a great peace of mind, especially when we come into summer. We can have a chiller down for service and one can still fail and we'll be all right. We have an aggressive platform with benchmarking and auditing and keeping track of all of our existing buildings. And I'll get more into the building EQ platform that we're using in a little bit. And the cornerstone piece of tying all of this together and really keeping everybody up to speed on where the buildings are performing and what's going on with these buildings is our careful attention to detail with our entire building automation system infrastructure. As far as high performance buildings go, we push for LEED Gold. It's actually our standard for every building moving forward. We've got 23 of them so far and another 5 that are in the queue. And we are able to do this, like I said, by enforcing it through our building codes. We are continuously updating our design, construction, and renovation standards. LEED Gold is that minimum. Unless it's like a donor-funded building, then we will allow some exceptions. We are very specific on our BAS specifications. We used ASHRAE Guideline 13 as a foundational document, and we are currently incorporating a lot of the sequence of operations, and particularly alarms management, that's mentioned in ASHRAE Guideline 36. This is just a detail here of our standardized approach. It's hard to see the red, I apologize for that. But our standardized approach for the tertiary pumps in every building to tie into that campus loop so that it is uniform from one building to the next. And we're going back and retroactively applying this in the buildings where that's not the case. And so that's really all about the new construction side of things. That the building design and construction, pursuing those 23 buildings, there's only, I think, 2 or 3 of those that are LEED O&M. But on all of our existing buildings where we're going in and we're doing retro commissioning or modernization projects, which we'll get to in a bit, every single one of those is teeing up those buildings for a LEED O&M. And as I mentioned before, with the case of every single project that gets performed at UCF, if it's going to have any kind of impact whatsoever on the energy profile or on the indoor air or indoor environment of the occupants, that project must be commissioned.
So for new buildings, as Nate stated, they've got their design standards, but their design standard for commissioning is really written around standard 202 from ASHRAE, the codified version. They do rely on the other guidelines that are out there, not NIBS, everything else, but hopefully in the future, guideline 1.6 for commissioning for data centers that's in development now. But the biggest thing is they really do require it for all projects, as Nate stated. Commissioning is a big component to them, and it works really well. You're on the slides, my man. So as every project starts out, and you always see the commissioning process, it's the owner's project requirements. So what's interesting about this one, this is for the Downtown Central Energy Plant. It's currently on version 4 of an iteration. It's a living document for them. We actually built this before the schematic drawings were actually issued for the chiller plant. So it was actually issued to the design team before they actually said, here's what we're going to do, because UCF wanted to make sure that they understood the intent of what was needed. I know there's a lot of projects that have OPRs. I know there's a lot of us that kind of get the OPR done as it needs to be done for LEED, but in this case, UCF is really pushing that aspect so they can make sure that the entire design team understands what they're up against. Another thing that they do in the design phase is the enforcement of life cycle cost analysis. So for any design project, they will actually require 3 to be completed. And what's great is they actually ask for the commissioning agent provider, yes, provider is the new word, to weigh in and review these. So what's up here is a chiller plant, a chiller analysis for the Downtown Central Energy Plant chiller. They really truly do look at a 20-year life cycle for the building. They do not select their chiller based on lowest first cost. And in this instance, they did pick the chiller that was the most efficient over that 20-year footprint as opposed to it. They figured out where to get that funding source. Sorry. Still on that, Scott, you're right here. Same thing for the District Central Energy Plant 4 was done. It wasn't necessarily the least expensive chiller. So they really do say, hey, we've got a sustainability plan, we've got an energy plan, but they actually follow through with it and look at that life cycle cost. So now, just hitting some different projects and different things that you see. This is really here because it's not always about energy, it is about the indoor environment. In this situation, it was a 3rd floor lab addition to an existing building, typical lab space. They had a lot with a high fume hood density. So when we were trying to write the commissioning test, we kept saying, okay, what pressure are you looking for? What range of pressure are you looking for to maintain in this? They weren't actively monitoring it. They weren't controlling to it. They were using offset. But we just wanted a feeling. And basically what we were told is, for those that local to Florida, they've used this, the SPTP test that they do a lot of healthcare facilities. That's not exactly accurate. The reason we kept pushing for it was this design using CFM offset was designed, I believe, for 25 CFM offset for a lab space that had a set of double doors entrance. For those that have done labs, you realize that, wow, that's probably not going to work. So we wrote our test to make sure that we recorded, you can see it up here, taking a pressure reading. The lab was actually positive to the corridor. The design engineer just kept saying, I want it negative to the corridor, just slightly negative, sort of negative. It was positive. So, you know, the lab controls company did send in RFI saying, are you really sure you want something this low of an offset? So it did end up getting increased, retested, and passed. But it's one of those things that UES standing behind the commissioning and making sure it worked. It's one of the interesting things is Nate said it's required on all projects. There's actually turnover documents the contractors have to fill out. For a laboratory project, every system has to be tested at least once. All systems have to be tested at least once before they'll issue a TCO. For classroom buildings, et cetera, they only have to test a certain percentage. It's a little bit looser. But for critical applications like this, there is no TCO without commissioning. It's really nice from the perspective of not commissioning a building that's already open. Next one. So this one was a small project for a dining facility that actually became a huge headache. It was designed with 2 pairs of hoods to be teamed with 1 fan coil unit, providing makeup, variable kitchen hood, black box. It'll work, don't worry about it. The A team had sequences on their drawings. All the controls and information came in and said, yep, we're gonna operate this way. So we went out and tested it. It did not work that way. All 4 hoods were working with both fan coil units. The 1 fan coil unit ramped before the other, even though they had differing makeup airs to the hoods. They realized it was a problem, so they basically just locked it in at 100%. So there goes the energy savings. There goes all this money, right? And it's tough. It's one of those things where it was a difficult situation, but we got the hood manufacturer, the AE, ourselves, UCF, and sat down and talked through, okay, how can we actually make your system work to at least capture some of the energy savings that it was the AE team was expecting with their energy model. So it's now varying slightly. Yeah. This is another one. UCF really relies heavily on duct pressure testing. A lot of times it looks like that's more of the AE's, quality assurance and why is commissioning getting involved. For UCF, it's just a matter of they want to make sure that it gets looked at.
You'll see why this is so important in a later slide as well.
Correct. Nate's got some information on why. So in this case, nice picture of the test materials, and it had a calibration date. Well, that's now within the range of calibration for when the work was done. The contractor started, didn't tell anyone, and when we went out to look and check, it was essentially these need to be calibrated? Yes, they do, and you're like a year and a half out. So what was interesting there is in the time it took for them to obtain, locate, get a device calibrated, they continued with the work on site. The picture on the right, you can see the green arrow, that's where they had to rip the return duct insulation off to do pressure testing, because they also believed they only had to test the supply duct, even though it was a fully ducted return. At the same time, they also learned they had to test the exhaust duct as well. So fortunately, UCF was kind enough to allow them to just cut it and reseal it and check it that way. But it was one of those things that it goes into the quality of construction. The energy side, Nate will hit on later how it impacts them, some of the studies they've done out there. So this is a controls integration matrix. Should have made the font bigger, I apologize for that. But it's from a controls integration meeting that we have. I wish we had had this at the dining facility. This kind of stemmed the necessity to have it on every project. This really is what it sounds to be. You are trying to get the controls contractor, the mechanical general, electrical, depending on what the BAS is communicating to, and making sure everyone is aware of how that communication is actually happening. Which protocol, what platform, does there need to be a gateway, et cetera. I think if we had done that in the dining facility, we would have gotten them to realize that no, that's not going to work for that piece of equipment. But in essence, what we're just trying to make sure is that everyone is currently aware. One of the things that always gets asked, and the way our team handles it, is we typically have this, and I don't want to offend any controls contractors in here, after the submittal gets rejected or revise and resubmit after the first issuance. I don't know anyone in here. I typically see about an 80–90% revise and resubmit on the first issuance of the control submittal. So what we try and do is piggyback onto, after they've had time to look at those comments, is then go and have this meeting and incorporate all the different items. And you'll start to find, and we'll list equipment that they're not sure. Like on this one, we listed the water heater because sometimes they want to monitor that. It's large enough, they want to monitor that energy for their profile. In this case, in this project, it was, no, we don't want to monitor it. It's small enough, we don't need it. But we at least had that conversation. So at the end of the job, when they're looking at the graphics or we're looking at different energy, they're not saying, well, I thought we were doing this. If you think about it, computer room, air conditioning units, I think you can get, what is it, Randall, like 1,000 points on some of them? Right, and so some of them, you get that 1,000 points, well, which do I want? I don't want all 1,000. Well, then it also becomes, does that map over properly? Or does someone have to actually map it within the control system? And you try and have those discussions so that you're doing it, in essence, on paper or up front before you're sitting on a bucket. What Randall just said is a lot of times those points of that naming is encrypted. So it makes it another level of difficulty to make sure that everyone's on board. Yes, sir.
Typically finding I'll run the BAS on a different IP or a different network than your actual utilized network for your buildings. So,
Yes.
So that's another thing you have to worry about is integration on that. No one ever brings it up to the BAS. And then they get there, they're like, oh wait, we have to run the IP cabling? So that might be something that might be really easy.
I didn't touch on it here because UCF's IT actually shows up to meeting, right? So the downtown CEP, there's another firm, guy sitting here that's commissioning a different building on the downtown campus. We're at the same meeting. The IT guy was standing there and he's like, okay, where do you want the drops? So they were talking to the contractors, where do you want our data drops? And currently now, when we're looking at August as a gotta be open timeframe for school to start, when do you want them? So from that perspective, I would say yes, on most jobs we need to coordinate it, but UCF is very savvy to that, and they make sure that that person is part of those meetings because that's part of that integration.
Yeah, and the way in which we're able to do that as well is facilities and safety at UCF actually has our own IT department that works for the police department. All of our servers are there. They're not the same IT department as the rest of the university that deals with all the student computers and computer labs and all the rest of that stuff. They're on their own world. Our world is locked down and dedicated, and the staff that's working on it in our IT department knows our world and knows what we're doing.
Right. Like Howard was at the last one and kept saying, when? When do you want it? When? I know where, when. Yes, sir.
So from your BAS, your equipment, to your next point back to your SQL, your AX, you have problems. I deal with campuses, so like BIT 25, integrated automation. It's always like from here to here, but the data collection, it's always sort of like a looked over area, and if your IT or projector into this or is it they like that wasn't really brought up. Have you had that kind of?
Well, that's exactly why when I was showing how our department is broken up and we have that smart infrastructure group, that is part of the role that they play, is maintaining that handoff between what is happening within the BAS environment, what needs to happen within the IT environment, what needs to be integrated across the enterprise platforms, maintaining those BBMD tables, all of that stuff. We have a dedicated group that is all they do, and that's what they do because it is so important.
So, and then this is UCF's preferred platform for communicating on commissioning projects, which is CX Alloy. They're here, but there's a lot of different providers. However, cloud-based web application, real-time data, sharing information. They can go in and look at issues, comments, et cetera. The biggest thing that we've done using this with UCF is that our checklist, we're actually gathering the information that their facility staff that are actually maintaining it have commented on and weighed in on what they want collected. So for them, it's not just serial number, model number, it's fan belt sizes, if it has it, quantity, size, filter sizes, quantity, and we export it out. They've actually imported it into their platform that they use for their facility side. So they've gathered that information without having to walk around and collect it themselves or beg the contractors to hand it to them. So it's been a great tool.
Yeah, it certainly has. The being able to acquire all of that information during the CVC process and then import that into our CMMS software, that unloads umpteen hours worth of trying to transfer that information over. It's a huge help. Plus, the other thing that we really like about this platform is that all of those projects, when they're archived, they're available for us for perpetuity. We can always go back. We can reference exactly what happened, what the conversation was, when it happened, reference drawings. All of that is all in one spot. And so we tag that documentation into our BAS through a hyperlink, as well as loading all of that information into the asset files in our CMMS software. So anybody at any time can get right to it and go back and find the history of why things are the way that they are. And so that feeds right into where I'm going to go next is, like I mentioned, the energy services team, we are primarily responsible for reducing the campus utility expenditure, but we also manage owner direct purchase continuing service contracts for all building automation, test and balance, and commissioning activities that happen at UCF. And that's really important because that right there, that is your trifecta of personalities that need to be working hand in hand with the owner to see projects through the commissioning process, through mechanical inspection, so these buildings can be commissioned. One of the things that we recently added to the mechanical inspection form is straight out of Florida Building Code C408.2. There's a little checkbox there now that says a preliminary commissioning report approved by the engineer of record. Yes or no? If there is not a yes there, that project is not passing mechanical inspection. I'm not giving it a TCO. You are not moving people into there until that building is commissioned. Foot down. And so what that does is, that's on all of the, the renovations, the minor projects, even the big major capital projects. And then we basically use that feeds into, so we know where those buildings are going to rack as far as the prioritization goes. And as far as all of the rest of the buildings go, we prioritize all of our buildings as far as what we're going to do from an energy efficiency perspective based on total cost per square foot, total O&M cost per square foot. So that's utilities and maintenance operations. From that list, and this does, in a higher education environment, this does kind of penalize your smaller energy intensive lab buildings. But you know what, there's a lot of savings that can be had in those buildings. So from that point, then we go through, we benchmark our facilities against a peer data set of buildings that rolls into, energy audits to develop scope of work for design and renovations of the projects. And then those projects repay back into the revolving energy fund. And that's how my department continues to sustain and fund itself. So we never really have to go back to the well. We're just using utility costs avoided to continue to reinvest in our buildings and in our infrastructure. And so this is a little kind of a pet peeve slide here that I kind of want to talk about. There's a lot of benchmark and disclosure ordinances that are out there. There's the Energy Star portfolio manager is the 800-pound gorilla of benchmarking buildings. But what we found at UCF is this just simply does not represent a higher education environment very well. It gives me scores that aren't necessarily representative of the actual performance of that building. And so we had Hanson conduct a pilot study of 10, the 10 highest EUI buildings on campus using the ASHRAE Building EQ platform to see if that was how we wanted to benchmark our buildings. And the reason why we did is the ASHRAE platform, A, it's going to survive any kind of government shutdown, unlike Energy Star, if anybody was using that during that time. B, it provides a level 1 energy audit, so it actually gives you that what to do next step that Energy Star doesn't do. And C, it incorporates a lot more space usage types than Energy Star. They both use the same CBEX database, but the Building EQ platform also uses all of the ASHRAE Standard 100 information, as well as all the research that's fed into that. So it contains all of the labs 21 data. I can differentiate between wet labs, dry labs, computer labs. That's hugely helpful in a higher education, at a university like ours. It gives us a much fairer score. And so based off of that project, Hanson also delivered a standard operating procedure document. It's about 25, 30 pages long or so that really walks step by step through the entire process. That way we can incorporate doing building EQs with the academic program in the mechanical engineering department and have students come out and assist with this with a set of instructions that we then can, from utilities and energy services, walk with them, help them conduct it, teach them how, get them going on their way, review that information, and then submit for those benchmark scores. And that's helping that ever-growing attempt to try to bridge the gap between the academics world and the real-world operations. So they actually get to see, under the curtain, if you will, at UCF, back in the mechanical rooms and stuff. And so our plan moving forward, based on the results from that, is we are going through and we're doing about 20 buildings a year, benchmarking them in the Building EQ, and that tees up whether or not we're going to do a modernization project, if systems need to be replaced, or if the systems are within their life cycle, native backnet controls, all right, well, let's retro-commission this building instead then. And so for the modernization projects, we have mandated that all of our energy audits comply with the newly published ASHRAE Standard 211. And typically, because we, like I mentioned, we have all of these under continuing services, we already kind of know in advance whose controls we want to have in which building based on what that building is doing. And we try to team up the same design consultants with the same commissioning agents so that they have that continuous relationship kind of going through. So when we conduct these energy audits, we actually have the BAS contractor and the commissioning agent typically come out and do that initial interview and site walk for those projects as well. So that starts that whole team early buy-in that develops that OPR and just kind of moves all the way on through. We typically have the same firm that does the audits do the design, and our goal is to do 3 to 6 of these per year. Wade, do you want to touch a little bit just on how deep down the rabbit hole these particular energy audits get?
Yeah, that's one of the interesting pieces is a lot of times we hear, oh, we're going to do an energy audit, and that energy audit really stays at a high level. It's really dealing with more deferred maintenance and those kind of things. And through the years, a phrase that was used that I know, and when I borrow it, it gets liked, which is interrogating the building automation system. And so Nate and his background with controls and the process that I've gone through is it tends to really be an energy audit, but it also really is a retro commissioning where we are trying to find all the different optimization, really trying to find all the details. You're going to do a modernization of this building, so you might as well find everything out. And we've got some examples later on, but it really is a blurred line. So when we say energy audit, it really lends itself a lot more towards retro commissioning of trying to find everything that can be improved.
Mm-hmm. Exactly. And so our modernization projects, they're typically building automation modernization projects. And if we find mechanical systems that also need to be replaced at the same time, or if there's additional componentry to those systems that we need to add in order to implement optimized sequences, this is when we go ahead and incorporate that in that energy audit. So when we're selecting the facility improvement measures for the design scope of work, it's already a known quantity what's going to be part of this project. Our focus on these projects, very intent focus on control schematic diagrams, the sequence of operations, what that BAS GUI is going to have on it, what type of information is going to be displayed, what's going to be hyperlinked, what's going to be available on it. Very careful attention to trends and alarms and how we're going to configure the point naming schema for our fault detection and diagnostics platform. All of this stuff gets incorporated in the design documents.
So for these energy audit modernization projects, step one is always dealing with, well, in this case, it's an energy donut. Someone thought, Nate, that it'd be more interesting than an energy pie.
I like donuts.
Donuts. So we've got the energy donut. One of the things that we're doing for this is we're actually using a calibrated energy model against the utility information. And it's done more so that when we suggest facility improvement measures later on, that we can actually check against something real. So when someone does a calculation and you look and you see here the lights are using 8% and somehow a measure says, oh, we're going to save 6% of the total building. Well, you might want to think about that again. Are you really going to save, 75% of the lighting with one change or one item, just as a simple thing? But we use it as a back check. We also do use it to create some of the facility improvement measures. So, and that's the thing that you're going to hear. Nate and I will typically only use facility improvement measures.
It was a long argument.
Over many months. So a lot of the documentation says you have to have energy efficiency measures or energy conservation measures and facility improvement measures. And facility improvement measures are just those that, well, they don't save any energy. But over the years of doing these is try and explain that to an owner of this is something you really ought to do for X, Y, and Z that doesn't save energy when their whole push is to potentially only just save energy. Sometimes those improvement measures actually use more energy, but it creates for a healthier building environment, or it's safer, or it'll meet code.
Yeah, so to eliminate the confusion, we just ask all of our energy auditors to give us one titled list. This is simply facility improvement measures, and then break it out, HVAC, lighting, envelope, et cetera, et cetera.
Right.
But it's just one contiguous list.
And this is from our projects. It's just in the, what goes in the executive summary of what's been recommended, little bits of information. It's not very different from other, FIM trackers that you see, but in essence, the key thing is it's nice not to have to try and convince someone of a non-energy saving item that's actually really crucial for their operation. They compare all of them together, and when you do that, sit down with them. So this is an example, Building 54 on campus. The CXA is in the room, actually. So we did the energy audit piece with the retro commissioning. The design documents are due, construction documents are due out Monday for permit and bidding. But so for this facility, what we looked at, one of the things we try and do on these is a pre-test and balance to get some readings. In this facility, they've got the PIU units, they're fan powered. Hey, why don't we get rid of that fan energy and just go to a straight VAV with electric heat? And we said, all right, well, we'll run a pre-tab. So when we ran the pre-tab numbers, we realized that those were required to get the air actually out of the outlets. And so we said, okay, well, maybe we can tweak the air handling units, see if we can beef them up or turn them a little faster, do some different things. And during that time frame, it became very apparent to UCF that these were not necessarily on their last legs, but they were fairly close. And by the time this project was done, why don't we go ahead and just replace the air handling units now? One of the other things we realized when we were doing this is these air handling units had 2 outside air dampers. Now, we're not in the north, so it's not a min-max for economizer. It was for HVAC, and the other one was for the smoke control system. That was pneumatic and remaining, and we weren't touching it. So part of this had to be dealing with making sure that those outside air dampers are staying there. Good luck, Earl. And the HVAC ones getting replaced. So, but in essence, we went through, and what you'll find is it starts to become the typical retro commissioning list of what you're recommending, in addition to doing the BAS controls, because it went through their process of benchmarking. Okay, this is a modernization project. Update the entire control system, but what else can we do within that realm? We've had a lot of different meetings. It's always interesting getting commissioning comments to look at from a different commissioning provider, but it's occurring. They've been there for all the walks and all the meetings, et cetera. So hopefully the rest of it goes smoothly, right?
It's working that way. All right, so for the buildings that don't need the systems to be modernized, but they're still really underperforming, like I said, this is what we get. You know, this is the dashboard that comes out of building EQ. This particular example, it's using 56% more energy than it ought to. BEQ is kind of like the HERS rating system. 100 is dead even. That's net zero. This is horrible. So we're halfway to horrible on this particular building. So, you know, these are really the checklists right here. Is the energy performance less than average? And I have a native backnet system, but my systems are still within their life cycle as far as mechanical is concerned. But our work order history and our BAS alarms are indicating that entropy is preying on this particular building. That makes it a perfect candidate for retro commissioning.
So this is an example of retro commissioning project, personal experience with a previous company. My cohort is in the room. We did the work here. What you'll see that's interesting is Nate's talked about how many, 20,000 tons of chiller. But if you look through this, you'll only see 16,000 because this was actually performed prior to the 4th Central Energy Plant being brought online. What's actually cool about this at this time, as we were doing the work, the design team was actually out there trying to figure out how their plants worked while they were designing the 4th Central Energy Plant. And it's a slightly complex in terms of different varying flows for min, max, whatever load, how they look at it. When you think about it, they had 3, now they've got the 4 plants. They're all combined on one loop, the pumping, how those work, which one gets preferential treatment when you're looking at an overall process. So what's cool about this, like I said, is we were retro commissioning this and trying to, and we're in essence helping the same firm that did this retro commissioning effort did the actual commissioning for DEP4, but I think, Nate, you guys are actually now recommissioning all of the plants.
Yes, we are. So since DEP4 is now online, we are going back through, and like you said, we're recommissioning the entire chilled water system as a whole as one unified system. We've already done the BAS point-to-point and retab, and we're rolling into the phase now where we're evaluating all of the sequence of operations, taking into account the efficiency gained from DEP4 and what we can do with that plant and where that plant was strategically located on a poor spot of the loop, and taking a look at all of those sequences as a whole. So we talked about duct pressure testing. I'm just throwing this up here just to kind of indicate some crazy numbers. So in one of our older buildings, math and science, I believe it was, there's a total of almost 130,000 scheduled CFM for that particular building. And we did a pre-tab on it and then rolled through with a duct cleaning and duct sealing project that's, you've read the ASHRAE articles. You've seen a couple of them. I don't know if this was the AirSeal product or not, but something that met the same ASTM as it. We were able to claw back 20,000 CFM by going through and cleaning and sealing up that old ductwork. And it did involve mechanical sealing where seams had busted and stuff like that. But then going through and actually doing the aerosolized sealing to that ductwork, we were blown away by that number, just frankly blown away. And so that is now a facility improvement measure. I almost called it a ECM.
I would have had to knock you down.
That is an improvement measure that we now consider on every single one of our buildings. And so one of the key drivers behind the onus of recommissioning all of these buildings is not just from the perspective of energy, but it's from manpower as well. We've got a small team of what we call the IAQ techs, and there are 5 BAS service technicians that, their job is to maintain the building automation systems on a day-to-day basis, but they're also the first responders to hot and cold calls. And last fiscal year, 66% of their billable time was spent chasing hot and cold calls. Now that's significantly better than it used to be, but that's still so far behind the 8 ball that they can't get out proactively in front of this and get these buildings tuned up. And that's where my team and the retro commissioning process is really coming through and helping get these buildings cleaned up so that they don't have to spend as much time in that building anymore. They're deployed elsewhere. So it helps get in front of the maintenance burdens and defer, it reduces that backlog. And plus the retro commissioning, when we get done and we systems manual all of this stuff, that's information that's now provided into the assets for those service technicians. So when they pull up their work order and the asset that's on there, anything that was tweaked or changed or updated about that system through retro commissioning is tagged right there in the information of that asset. So they know what was done and where it needs to be put back to. And so, like I mentioned, our strategy for recommissioning these buildings is a very stepwise procedure. The first thing is do a complete building automation point to point. Verify every sensor, every actuator, every relay. Is the building automation system itself functioning as intended, all its little parts and pieces? Once that answer is yes, then we retab that building to reestablish all the CFMs and GPMs and BTUs and make sure that they're going where they're supposed to be going. And if the equipment is not able to do it anymore, then we record that deficiency into that asset so it can get on a capital renewal plan. Now that BAS has gone through point to point and it's been retabbed, I can trust the telemetry that's coming out of that BAS. And so then we can roll right into functional performance testing, running the equipment through its sequence of operations, and then taking a look at that time. Are there optimization strategies that we can deploy and tweak and update these sequences, like static pressure reset, or there's a whole laundry list of them that you can do once you're in there and you're updating these sequences. And then when we're done with all that, like I said, it's very important to record everything that you did and update that systems manual. It's supposed to be a living document, so help the thing live. Update it, put that into the CMS software, hyperlink it into the graphics of the control system so it's right there at the fingertips of the techs who really need it. And then once all of that is done, then I know that building is giving me trustworthy data. The systems have been validated. That is a recommissioned building that's run it through our fault detection and diagnostics system and start generating monitoring-based commissioning results off of that. Now we still intervene. We don't let this thing generate work orders automatically, not yet. We're still intervening those back at our team and evaluating if this is a real work order or not, and then getting in touch with work control. But once we're satisfied with the confidence level of what this is generating, then it is our intent to have that automatically generate work orders to our work control center. All right, so that's been our game plan as far as the energy conservation and facility improvement strategies at UCF. Let's take a step back now and kind of look at a 100,000-foot view of really what we're up against. And so our goal, as I mentioned earlier, is carbon neutrality by 2050. Well, what does our carbon impact look like right now? Like I said, it's almost 800 million kBTUs of energy that we're using. And so let's just lick our thumbs, stick it in the air and say, okay, if we go through and we modernize these buildings and we retro commission these buildings across a campus of 180 buildings, I think I can realistically expect a savings in the neighborhood of about 30% across the board. I'm going to have some buildings that are going to do great. My energy intensive lab buildings aren't going to save, it's going to kind of be all across the board, but I'm putting a stake in the ground that it's going to be somewhere around 30%. Well, that's only going to drop me to a little over 500,000 kBTUs. And so if I were to try to generate that with just PV, because wind is not an option here in Central Florida, I would need 136 megawatts of solar. That's over 360 acres. That's not realistic. Now, this is just bad math, back of napkin stuff, and it doesn't incorporate energy storage, but that's the challenge that I'm up against. Even if I am successful and UCF doesn't build any more buildings, which is, we're under construction forever, so let's face it, that's not realistic either. I've got a challenge ahead of me. And right now we're a 30 megawatt site. So if I'm generating 136, where's that extra 100 going to go? Duke's not going to let me put that on their grid. No way. Is it going to be cost effective or even safe to try to store that much energy? So these are some of the strategies that we're having to look, really moving forward. And this is kind of some of the ways in which we're doing it. Distributed generation is going to come from a lot of different areas. Hydrokinetic is an interesting one in that we currently purchase about 1.1 million gallons a day of reclaimed water for irrigation and to feed a cooling tower.
Right.
And that water comes to us at significantly higher pressure than we need to use it at. So rather than just using pressure reducing valves, we're actually having students, as part of some senior design projects, research as to whether or not there are energy recovery turbines that can go there and do the same job and give me some of that power back. I already paid for it in my water rate, so I might as well get some juice out of it. We only have 140 kW of solar right now, which is a drop in the bucket, and we are in exploratory talks on grid scale energy storage because we have so many research buildings. The cornerstone really behind all of it, though, is the building automation system. Another reason why we're going through and we're modernizing all of these buildings is that I have native backnet control systems that can respond and react in a microgrid environment. So I can do active demand management once I do have renewables and energy storage at play. And we're also doing collaborative ventures, in particular with Siemens right now, on both a digital grid lab and I call it smart buildings lab, but it's really an autonomous buildings lab, where they're pulling in all of the BAS data and they're running their own advanced analytics on it, which is going to be very interesting to see because they're doing it on the buildings where their controls are at first. And then the digital grid lab is where we're actually simulating where we're going to put PV, what kind of impact is it going to have? If we add energy storage, what kind of impact is that going to have? And so I've got graduate level students and PhD level students and postdocs that are simulating all of the different possible scenarios of a distributed generation network at UCF so we can plan ahead of where we're going to have voltage spikes as a result of PV or other different scenarios that we might not otherwise know until we just start indiscriminately slapping solar out there on roofs until transformers start popping. Like I mentioned, we're only at 140 kW right now. Our interim goal of 2020 is to achieve 15% of our energy from renewables. And the only way in which we're going to get there is if we move forward with a utility scale ground mount array. We've got a 15 megawatt that was on again, off again, on again, off again. Now it looks like it's back on again. Changes in leadership. And then we're going through and we're prioritizing all of our rooftops, both by what capacity from a solar generation perspective they have, but then second phase is that roof structurally sound? Can I put PV on that roof? And so we're going through and analyzing all of that right now. Looks like we'll probably be able to get another 6 megawatts out of our roof and about the same out of our parking garages. The eventual plan is hopefully that all surface parking goes away. So I'm kind of kicking that can down to the end of the road. And I already mentioned hydrokinetic energy, but another thing that we're looking at as well is we have a pretty significant waste stream, as you can imagine. So we're in the beginning phases of a waste stream audit right now so that we can get an understanding of what exactly that is, as well as landscaping, and see if some waste to energy biodigesters make sense. It's not really going to help us from a total carbon perspective as far as source one, but if it reduces a significant amount of waste pickup, that cuts down on our source two emissions. So at the 10,000 foot level, here's the numbers. Over the last 12 years, we've avoided almost $31 million in utility costs and reinvested almost all of that back into infrastructure improvements. The rest of it is like in the works right now. 23 of our buildings are certified under the LEED program, and we've reduced our campus source EUI by 42.4% since 2007.
So in summary, just in terms of this process, this plan, you can see what UCF is pushing for is a dedicated and diverse team. But in reality, everyone that I've worked with out there is in line with that purpose of trying to get there. It's great working relationships, not just Hanson to UCF, but they've got a lot of consultants under continuing contracts that they use, that they have the same relationships with UCF to a degree. And then not just that, is the relationships between those consultants working together, right? So Scott and I are working on, I'm working on the central energy plant. He's working on a building that's getting the water from the central energy plant. We have to work together, otherwise it's not going to work well for either of us. And so what you find is there's a lot of professionalism and respect between those teams and an understanding of working towards that goal. So it helps it be successful, and UCF fosters that. Nate's touched a lot on the different living documents, the systems manuals, the things that they're trying to keep up and keep current for all their operators. And that's been will be, and it still is a big thing. The academic side, we touched on it very briefly, but there's a bigger push there, which is when you start to get the academics behind some of these platforms of how much solar can you add and how can we do that in the mechanical department, how can we do more of the BEQ and the other projects, is now you have a different source of support for different projects and trying to get things done. So it helps, and it's a big part of that plan. And the last thing, and this is one of the things, when we're going over this presentation, I said, Nate, have a plan. It wasn't on the slides. You got to have a plan, right? Have a plan.
You have to have a plan.
So
your first plan's probably crap. Start over. Learn from it. Revise, resubmit. Revise, resubmit. But have a plan, and that plan should also be a living document.
Right. So with that, gladly take any questions.
Great efforts on your part. Question in regards to better commissioning. Do you actually do M&B as part of that? And what kind of success have you had, overall?
We absolutely do M&V. We usually do the IPMVP whole building option C for M&V, and that's so that project can repay back in the revolving loan fund the amount that we invested into that project. What we do is we use Energy Cap right now to monitor about 550 submeters around campus because we're a primary metered site. We only get 2 power bills, north substation, south substation. Everything inside that campus grounds, we monitor and we manage that balance sheet. And so we have to do that in order to mark a baseline period of prior to that project being completed, hold off while it's under renovation, under construction, because that's bad data essentially, and then mark a new period of recording the M&V period after that. And then what we do for all of those is that project will continue to take the utility costs avoided, transfer it back into the revolving loan fund until that project is paid for itself, and then we round up to the next full year for a little bit of interest and to help that account slowly grow.
Yes, sir.
Hey, you mentioned the campus has about 180 buildings. Are all those buildings serviced by a building automation system?
No, not all of the buildings are BAS. I've got a lot of little concession stands. I've got some standalone buildings here and there. The intent is that they eventually all will be on a building automation system. Some of the little itty bitty concession stand stuff, that might just be a backnet thermostat that's in there so I can pull some kind of information, some extra points out of it. But the intent is to get it all under one enterprise level platform of building automations. We don't have one particular vendor. Right now we've got 3 that we're working with on campus. We have about 5 different systems out there kind of as a whole right now, though, with spatterings of others. But
don't forget the extra hiccup, which is you don't actually operate in some of those buildings. They're not all E&G.
Not all of the buildings are state-funded buildings. My team focuses primarily on the state-funded buildings. Housing, athletics, stuff like convocation core, stuff like that falls outside of what we are primarily focused to do. If we want to do projects or they want us to do projects within their buildings, they're still state buildings, they're just not state-funded buildings, then we enter an MOU with them. And basically, it looks like an ESCO contract, essentially, but internally performed.
Just another layer.
Mm-hmm.
So. Any other questions? Yes, sir.
Have you funded any of your research out of your energy savings? Like when you talk about your graduate PhD level students doing research for that, are you funding that out of your energy savings, or are they just doing that as part of an academic?
I'm not funding any graduate level research right now. Those are usually grant funded programs that will enter an MOU because we've got all the data, we've got all the guts that they want to have access to. But that said, we do fund undergraduate projects particularly for their mechanical senior year, senior design capstone projects. So I've got a number of different things that we're funding at that level. So we can interact with the students early. I'm also using it as kind of a pinpoint radar of, all right, which one of you are 11s? I want you as an intern and you as an intern, and I'll give you to Wade. And
You know we got the one you want.
I know you got the ones
okay,
that I
just
want.
making sure. Yes, sir.
You mentioned you have like about 23 LEED buildings, and so you have a charter, like most of the universities who adopted that, either silver or gold. Well, what if, you also mentioned about Section 408, so did Orlando adopt the 2018 special inspection for the commissioning compliance checklist? Because you mentioned Section 408, and if unless there's a special inspection addendum to it, they actually don't have to enforce it. So with universities, when it's a university property, you say yes as long as the name's on it. But ACC and residential dorms, or they all have to come in, they usually say, yeah, we're developer-based, we don't have to do that.
The developer-based stuff is kind of it's a different scenario. It's like I mentioned, those other buildings that they're still UCF buildings, but they're not state-funded buildings. What we've worked out, we're our own authority having jurisdiction. We have our own BCO. We have worked out with that BCO. We had to provide basically documentation, a letter, and all the certifications to attest that we are in, what was the language in 408, an approved or authorized provider of commissioning services.
Legalese.
Yeah, legalese. So we've done our due diligence as far as the legalese perspective with our BCO. So for all the little minor projects where it's, it's like one little lab build out, it's not even worth a proposal time for one of our consultants to try to mess around with it, that we go and we self-perform these things on. We've got that in place. But the developer-led stuff, that type of language, if it's not incorporated early on into the lease agreements with that, then we're kind of at the mercy of it does count against our carbon footprint, and unfortunately that's one of the lines in the sand that we have not really taken up the fist fight with yet.
Those become Andy's headaches, don't they though?
Eventually.
Yeah, okay. Yes, sir.
Yeah, just on the last slide, that was your source EUI was down 42%. What advantage do you get focusing on source EUI versus site EUI?
That's a great question. Almost all of our peer universities report and cite EUI rather than source. We use source because we generate power on site. We have our own cogen plant. We do have renewables that are going into play. We are going to add more renewables into play. That shifts that site source ratio multiplier down a little bit more. It's more advantageous to us. Plus, at the end of the day, if we're really going to try to achieve carbon neutrality, well, then source EUI is the metric that we should be following because that's our true impact.
Did I see another question over here?
It looks like you're using SkySparker as a monitoring-based machine tool. Can you talk a little bit about how you structured your team to respond to the findings on a routine basis?
It's still a fluid environment. Right now, my energy service team captures those sparks when they're generated and does that initial root cause investigation. If it really is something that's a broken component or performance degradation of a piece of equipment, then we will generate a work order for that response team to go out and fix whatever it is that's broken or take it to that next level. But right now, like I said, the human intervention component of it, my team is still intersecting that data.
In my experience with owners, campuses, large amounts of buildings, the sheer number of BAS alarms that can be generated from an indicated date would be going to maybe the part of the UCS strategy.
Okay, so the question was, in most large campus applications, the number of BAS alarms more or less can be daunting, and how does UCF treat that? And that's a very valid point. That was kind of why early on I keyed in on the fact of, there's some really good language that was developed in ASHRAE Guideline 36, particularly around alarms management and hierarchical alarms management. If I have a chiller or the tertiary pumps are dead and I'm not flowing water, well then of course every room in that building is going to be screaming hot red. I don't need 800,000 alarms telling me that I'm hot, I'm hot, I'm hot. I need one alarm that says tertiary pumps are dead. And so that's what we're going back and we are retuning all of the alarms and the trend configurations as we're recommissioning or retrocommissioning these buildings. So in the buildings where we haven't gotten around to yet, that's still noise. Those 800,000 alarms that are in that building, that's noise. Unless somebody's actually calling up saying, then they're more or less not really treating those alarms as well as they ought to be.
Anything else? Are we good? Yes, sir.
So recognizing that UCF national champions had the best football team.
Go Knights.
The major football teams in America. Does that football team credit your planning program for their success?
No.
Listen,
They don't need to.
I'm proud of you. You made it through the whole thing without mentioning it. I'm glad that your money was well spent to get that noted. Any other questions? All right, hearing none, thank you guys for coming.
Thank you.
Appreciate your time.